Welcome to class. I'm your professor for today's explainer, and we're going to synthesize a massive amount of foundational material to get you completely ready for your biological anthropology exams. Whether you're reviewing for midterms or gearing up for finals, this masterclass is designed to distill exactly what you need to know at the bachelor's level. We've got a lot of ground to cover, from the origins of evolutionary theory to the anatomy of our closest living relatives, so have those notebooks ready. Here's our agenda for today. 1. Defining biological anthropology. 2. Methods of the trade. 3. Evolutionary thoughts and theories. 4. Our primate relatives. And 5. Deconstructing human variation. Starting off with Section 1. Defining biological anthropology. Scope and shifts. Okay, here's what you absolutely have to know from the exam. This is fundamentally an integrative science. We're looking at humans as biological organisms, sure, but heavily influenced by an evolutionary framework. We aren't just studying bones in a vacuum, right? We're studying human biology, genetics, growth, and adaptation in the context of millions of years of evolution. It's really about answering the how and why of human existence, linking us to both our extinct ancestors and our living primate cousins. Now pay really close attention to this historical pivot. Before the mid-20th century, this field was known as physical anthropology, and honestly, it obsessed over static measurements. But S.L. Washburn's 1951 push for a new physical anthropology was a total game changer. He forced the discipline to look at the dynamic genetics and biological processes behind adaptation. It was like shifting from just describing a car's paint job to actually looking under the hood at the engine. And that is exactly why we call it biological anthropology today. Moving to Section 2, Methods of the Trade, from calipers to DNA. You definitely need to memorize this concept. Anthropometry literally translates to the measure of humankind. It's the foundational, universally applicable method we use to assess human morphological variation. We use standardized landmarks, like the Frankfurt horizontal plane for the skull, to ensure that a measurement taken in a lab in New York is exactly comparable to one taken in the field in Kenya. It's inexpensive, it's non-invasive, and it is completely fundamental to our entire discipline. It's actually crazy to see how fast our toolkit has evolved. In the 19th century, researchers relied almost entirely on craniometry, literally measuring skulls with metal calipers. By the early 20th century, we had standardized visual observations. But the massive leaps, those happened in the 1950s with serology and blood groups, eventually arriving at the 1990s with full-on genomics. I mean, we went from measuring the outside of a skull to analyzing the microscopic DNA blueprints of human migration. On to Section 3, Evolutionary Thoughts and Theories. You cannot understand modern genetics without understanding the theoretical battles that came before it. It's kind of wild to think back to ancient Greece, where folks literally believed in spontaneous generation, the idea that complex life just sprang up from mud. We then moved to Cuvier's 18th century catastrophism, which argued for successive divine creations after global disasters. But our true scientific journey arrived in 1859 with Darwin's framework for natural selection, which ultimately culminated a century later in the modern synthetic theory. Here's the kicker. Darwin was a genius, sure, but he was missing a huge piece of the puzzle. He gave us the what and the why of evolution through natural selection, but because he didn't know about DNA, he couldn't give us the how. It was the rediscovery of Mendelian genetics that finally provided that missing link. The synthetic theory, or the modern synthesis, marries Darwin's natural selection with Gregor Mendel's laws of inheritance. So in modern biological anthropology, we defined evolution simply as the change in gene frequencies in a population over successive generations. All right, listen up, because for the exam, you absolutely must be able to list and define these 4 core mechanisms that drive the synthetic theory of evolution. Number 1, mutation. This is the ultimate source of all new genetic variation. Number 2, natural selection. This is the directional force favoring traits that enhance survival and reproduction. Number 3, gene flow. That's the exchange of genes when populations migrate and interbreed. And number 4, genetic drift. This is the random, chance fluctuation of gene frequencies, and it's especially powerful in small, isolated populations. Know these 4 inside and out. Section 4, Our Primate Relatives, the Comparative Approach. Now, you might be wondering, why do we spend so much time studying monkeys and apes in a class focused on humans? Well, because to truly understand human biology, we have to use a comparative approach. Remember, humans are primates. By studying primate anatomy, ecology, and behavior, we are essentially looking into a living window. It provides us with baseline models to understand the ecological pressures that shaped our own evolutionary ancestors millions of years ago. We're looking for evolutionary trends, what we retained, what we lost, and what we highly specialized. Even though humans are incredibly unique, primarily due to our obligate bipedalism and massive brains, we share these fundamental traits with our primate cousins. We all have 5 digits, flat nails to protect our sensitive, tactile pads, and opposable thumbs for a power and precision grip. We rely heavily on stereoscopic, 3D vision rather than our sense of smell. And crucially, we have very large brains and a prolonged period of juvenile dependency, which allows for intense social learning. This just brilliantly demonstrates our deep shared evolutionary history. Okay, pro tip for your practical exam: if you're handed a fossil skull, look straight at the teeth. It's a dead giveaway. Apes have a rectangular, U-shaped jaw with massive projecting canines and a diastema gap. Humans, on the other hand, went through a dietary shift, plus our tool use replaced our teeth as weapons, so we ended up with a beautifully smooth, parabolic jaw with small, non-projecting canines. And it's a similar story with the skeleton. Ours completely re-engineered itself to handle the weight of an upright bipedal stride. An ape's spine is a single, gentle C-curve, but a human spine? It has an S-curve to bring our center of gravity directly over our pelvis. Furthermore, the foramen magnum, that's the hole where the spinal cord enters the skull, shifted from the back, in apes, directly to the bottom center in humans, balancing our heads perfectly on our upright spines. And finally, Section 5, Deconstructing Human Variation. Here, we have to critically analyze one of the most historically misunderstood, yet culturally significant topics in our field: the concept of human variation and race. Historically, early taxonomists tried to pigeonhole incredibly complex, continuous human diversity into arbitrary, discrete boxes. Scholars like Bernier, Linnaeus, and Blumenbach tried to draw hard lines based on skin color or skull shape. Even worse, Linnaeus and others often injected severe, ethnocentric cultural biases into their biology, literally linking physical traits to supposed personality types. This was deeply, deeply flawed science. For your exams, and honestly just for your broader understanding of the world, you must impartially recognize what these early scholars believed, while understanding that modern biological anthropology completely rejects race as a biological reality. Let me be very clear here. Race is a very real social, cultural, and historical construct that profoundly impacts people's lives. However, there is zero scientific, genetic validity to dividing the human species into distinct biological subcategories based on traits like skin color. Now, don't get me wrong, human variation is an absolute biological reality, but it is continuous. Modern genomics proves that traits like skin color, hair texture, and blood type vary gradually across geography due to adaptation to local environments and constant gene flow. They do not exist in fixed racial boundaries. In fact, geneticists have proven that there is far more genetic variation within any given local population than there is between 2 completely different global populations. This historic UNESCO statement really hits the nail on the head regarding the definitive scientific consensus. All human beings alive today belong to a single, highly mobile, heavily intermixing species, Homo sapiens. Our physical variations, whether it's the amount of melanin in our skin protecting us from UV radiation, or our body proportions adapting to high-altitude cold, are a beautiful, functional product of evolutionary adaptation. Biologically, we are one tightly knit species. As we wrap up today's explainer and you finalize your exam prep, I want to leave you with this provocative thought to apply outside the walls of the classroom. You now understand the evolutionary mechanisms of adaptation and the reality of genetic continuity. So how does mastering the true science of human variation empower us to dismantle the arbitrary social constructs that have historically divided us? Think critically about that as you study. Good luck on your exams, class, and thanks so much for joining me today.